Hello friends and welcome to Abyss classes. Okay, as you know, the today's series is your Learn Quick and Easy series. In this particular series, the concept what we are discussing has already been very detailed discussed in the previous classes. This is kind of a summary or a revision class to fast forward what you have already learned, and it's kind of वो बोलते हो ना आप लोग के one night before exam preparation kind of stuff. Okay, so here the aim is to whatever you know, the main concepts, main stuff which is going to come in the exam, that point of view we are targeting. Okay, so without wasting your much time, let's go for the your topic. So today's topic is what your vapor pressure. Okay, so what this vapor pressure we have been spoken is it's the pressure. It's the pressure exerted by the vapors of a liquid which are in phase equilibrium with the liquid. Now let us understand what is this means. Okay, so you take a closed container. You take a container, okay, and close it. Obviously you have some liquid inside it. You have some liquid inside this container, okay, and you have closed it with the help of a lid. Now you are heating it. Now what you are doing? Come on. Now what you are doing? You are, sir, we are heating it. Okay. So here what you have? Sir, we have air here. Here what you have? You have water here. Let us say water. We have took water here. What is present here? Air. So air has some air molecules, but we know the air molecules are very scattered. Okay, they are scatteredly packed. They are not densely packed. So that means they have enough space between them. That means they have enough space between them. So because you are heating, the surface will first what it will try? It will try to get the energy. So when it gets the energy, the kinetic energy increases. The kinetic energy increases, it breaks the bonds between them. It will break the intermolecular forces, the bonds which have made. So it will break it. Then what? It will try to now escape. It will try to escape. But what is there in the immediate surrounding? Immediate surrounding air is there. But how it will escape when there is no space? Correct. That's why we have to air. Because in air we have enough number of space. Okay, enough space is there which allows the water molecules to take place. So water molecule starts occupying space. So what happened? Water molecule starts occupying space. After some time what will happen? Because there is continuously this water are going and mixing up there will be a point where the above this area will saturate. Saturate means what? It cannot take more water molecules because now they are packed. Okay, and by this time the energy which has already went up, they will be losing little bit of their kinetic energy. Okay, so before what was going on? Sir, vaporization was going on. Okay, that's why liquid formed vapor. Liquid formed vapor and it was going up. It mixed with the air molecules present there. Initially air has enough space between them. So that's why water molecules were easily occupying space. After some time, or there will come a time where the amount of air molecules are or the space here is densely packed. That means it cannot take more water molecule. This is only we call saturation. That means a saturation level has reached where the air present above this liquid surface cannot take more water vapor. Okay, at that point the molecules of water will start losing their energy, their kinetic energy will drop down, and what they will become now? Now they will start to condense. So condense means what? From vapor to liquid. From vapor to liquid, condense, liquid to vapor, vaporization. So they will start falling down now. Now they will start condense. After condensing what? Become heavy. Gravity, so they will fall down. Now they will fall again. Where? On the liquid surface itself. But then again there is some space. Present here. So again your water will start evaporating and will try to occupy the space left. Correct. So this condition will continue. Until the vapor pressure, the vaporization is equal to condensation. So there will be a time where the amount of water vapors going from liquid surface and the amount of liquid after condensation coming down to the liquid surface will become equal. So the rate of vaporization will be equal to the rate of condensation. At that point, the pressure exerted by these vapors on the liquid surface, we call it as what? Vapor pressure. We call it as vapor pressure. So when the rate of vaporization is equal to rate of condensation, we call it when it is in phase equilibrium with the liquid. We call it when it is phase equilibrium with the liquid. Understood? Understood the first point? Okay, it's the pressure exerted by vapors of a liquid which are in phase equilibrium with the liquid when the rate of vaporization equal to rate of condensation. Okay? Good, very good. So that means so you're boiling this. Okay, we'll come to boiling after some time. Let's come to boiling after some time. Now we'll go for the second point. What it says, it means vapor pressure increases with temperature. Vapor pressure increases with temperature. See, again I am telling you, want the detailed concepts of this. This is already explained in the vapor pressure concept. Okay, you'll find that link in the description. You'll find the link in the description. Please follow that link. Okay, if you have any doubt about how what is vapor pressure, how it increases with temperature, it is explained there. Okay, this is the summary video. Correct. So now see, it increases with temperature. So when at 0 degree Celsius, these values are for water. These values are for water. At 0 degree Celsius, what is the vapor pressure rate of water in kilopascal? 0.6108. 0.6108. At 30 degree Celsius, okay, the value is around 4.25 kilopascal. 4.25 kilopascal. At 60 degree Celsius, these all are in degree Celsius. The vapor pressure is nothing but 20 kilopascal. And at 100 degree Celsius, we know it is how much? Atmospheric pressure. 101.325 kilopascal. So what you can find the trend here? As the temperature increases, what happens to the vapor pressure? As the temperature increases, vapor pressure of any liquid increases. As the temperature increases, vapor pressure of any liquid, what happens? It increases. Okay, got it? Now, boiling occurs when the external absolute pressure exerted upon the liquid and the vapor pressure of the liquid are equal. That time we say there will be a boiling. This means what? Now if you understood this, please allow me to erase it. Okay? Please note it so that I can erase it. Okay? Okay, I'm gonna erase it. So now to understand this concept of boiling, I need little bit of your attention. Please follow it. So now this is your container, correct? Container. In the container you have some liquid. What you do? So your pressure is equal to constant. I am assuming your constant pressure. Pressure is constant, and you are heating. This is what you cook. You cook rice, you cook vegetables. Correct, na? In your kitchen. So what happens is you are increasing the temperature. When you are increasing the temperature, we know water boils at 100 degrees Celsius. We know water boils at 100 degrees Celsius. Means when the temperature of the liquid is greater than or equal to its saturation temperature, we call it boils. We say it boils. What? When the temperature of the liquid is greater than the saturation temperature, we call, okay, the boiling condition has reached. That means water will now forms bubble, and you can see that dubu, it will boil. ठीक है ना? Boiling means what? What is the important thing in boiling? Bubbles. Remember, bubble. Unless there is no bubble, you cannot say it's boiling. So for boiling, bubble is compulsory. Okay. So now it will boil. Okay. Very first condition, simple, you understood. Where what is constant? T liquid is greater than T saturation. Where your pressure is constant. Your pressure is constant. And this, for water, the boiling temperature is what? 100 degrees Celsius. And what is the pressure? Atmospheric pressure. So 100 degrees Celsius, vapor pressure 101.325. That condition water boils. That condition water boils when it crosses the 100 degrees Celsius. So sir, do you want to say if the pressure of liquid has some relation with its vapor pressure? Are you trying to say that? I'm like, yes, I want to tell that. So the second condition of boiling is when the liquid pressure falls below the vapor pressure for the liquid, means at certain pressure the liquid starts boiling. So that is vapor pressure. So your liquid pressure falls below the vapor pressure, then also your liquid will start boiling. Now let us try to understand that. How does that happen? Okay, how the second condition happen? Sir, first condition we already know. We do that in our kitchen. हम मैगी बनाते हैं. We make rice. Okay, we cook vegetables. So we understand the first condition, but we do not understand the second condition. Please try to teach. See, so now this is again your liquid. This is the liquid and this is the free surface. Okay, so we know the surface of any liquid have some energy. We call it surface energy. So surface energy, the energy of the molecules present in the surface are higher than the energy of the liquid present in the bulk matter. So but this is at some temperature 25 degrees Celsius. Let us say this is at a temperature how much? 25 degrees Celsius. Water at 30 degrees Celsius. Okay, it is 30 degrees Celsius. So every time it will be trying to, because of it has more energy, they will break the bond and try to escape. But while they are escaping, you have something known as atmospheric pressure. Correct, na? This is open to atmospheric. So the atmospheric pressure is not allowing big amount of energy or more amount of this vapor to continuously mix them. There is some mixing, but it is not good enough. It is not big enough for boiling condition. So that when the boiling will start, the surface energy will pass, then only the bulk molecules will come. Then only the turn for the bulk molecules will come to go up. That means they will form bubble. So what you have to overcome this. In order to overcome this, what we do, you heat. So after heating, what you are doing, actually you are giving this energy, the surface of the molecules which are present on the surface, you are giving them some energy to overcome this atmospheric pressure. That only we call vapor pressure. When the atmospheric pressure is equal to your vapor pressure, boiling starts. Okay, and we have defined K at 100 degrees Celsius, the vapor pressure is how much water? 101.325 kilopascal. That is nothing but the atmospheric pressure. So that's what it told. Boiling occurs when the external absolute pressure exerted upon the liquid and the vapor pressure of the liquid are equal. That means here, because it is atmospheric pressure, the energy required was more. The energy required is more. Now what will happen if I decrease this? I will connect a pump and I will try vacuumizing it. If I try vacuumizing it, this pressure will become low. And when this pressure is becoming low, it has the less energy compared to the surface energy. So surface energy is more, this is less. So but now the surface molecules will try mixing up. Then the bottom bulk part again will come top and they also will start vaporization. So that means what? Bubbles will start formation. So boiling will occur. So when your external absolute pressure falls below the vapor pressure, then your boiling starts. Sir, what is vapor pressure here again? Let us say you are 30 degrees Celsius. What did I tell you? What is the vapor pressure of the liquid at 30 degrees Celsius? How much? 4.25 kilopascal. So if the pressure here comes below this 4.25 kilopascal at 30 degrees Celsius, yes, start boiling. water will start boiling. I hope you understood. I hope you understood. Okay? So, this was the third point. Now pause the video and note it down. Okay? I'm gonna erase it now. Okay? So you understood these 3 points. These 3 points was very important in vapor pressure point of view. This is how, and this is the boiling condition. Okay? These 3 points are very important with the boiling condition which comes in exam. Which comes in your exam. Okay? So next we'll see how this vapor pressure application, how we are using the vapor pressure in our what? In our barometers. How the application of vapor pressure uses in what? Your barometer. See. Now you guys, you know mercury. Yes or no? Mercury has very low vapor pressure. But by default the property of mercury is such that mercury has low vapor pressure. Now let us understand what does this low vapor pressure means. What does the low vapor pressure mean? Now if you remember, while teaching you the first point of the vapor pressure, I explained you a vapor pressure concept. Like this I took, okay, and I took water there. Now I'll take mercury. Now what I'll take? I'll take mercury. Again I close it. So by default, mercury has what? Low vapor pressure. Mercury has low vapor pressure. Okay. Now I told you vapor pressure is the pressure which is acting by the vapors of the liquid which are in phase equilibrium with the own liquid. That means the amount of vapor applying pressure on the surface of the liquid is less. Okay. That means what? The amount of pressure exerted by the vapor of mercury is less. Now why this happens? Because less number of molecules are here. Because less number of molecules are present. As less number of molecules are present above the surface. Now next question is why less number of molecules are there? Next question is why next number of molecules are? Because only few number of molecules escaped after gaining sufficient energy. After gaining sufficient energy, only few number of molecules are only escaped. That's why less number of molecules are present above the surface. Because less number of molecules are present above the surface, the amount of pressure exerted is less, hence it is low vapor pressure. Now why few number of molecules escape? Because of strong cohesive force. Because of strong force of attraction between mercury molecules. Because strong force of attraction is there, that's why only few number of molecules manage to escape after gaining sufficient energy. Because few number of molecules manage to escape, less number of molecules are present above the surface, hence the pressure exerted by them on this means less. Less the molecules, less the vapor pressure. More the molecules, more the vapor pressure. But less the molecules, because they have more strong force of attraction, that's why they are not coming up. They are not coming up means what? What is happening? Sir, boiling is difficult. That means boiling is becoming difficult. That means boiling is becoming difficult. Because boiling is difficult, now on the barometer, in the barometer, which is a pressure measuring device, I can use mercury. Why? The first point is because it has low vapor pressure. Because it has low vapor pressure. That means if I use mercury instead of barometer, it easily won't boil, it won't vaporize, because the boiling is very difficult. Hence easily it won't vaporize. Understood? Interesting? Yes or no? Okay. Then second you can tell, sir, it has high coefficient of thermal expansion. Then you can say this, high coefficient of thermal expansion. High coefficient of thermal expansion means it has high sensitivity. It has high sensitivity. Means for small change in temperature, you will find a noticeable expansion. There will be a noticeable change in the mercury levels layer, so that you can read even if there is a 0.5, 0.6 degree Fahrenheit change. Okay, so that's why high coefficient of thermal expansion. Second condition. Third, okay, it does not wet, or it do not wet the surface, because why? Because the cohesive forces are greater than the adhesive forces. Because the cohesive forces are greater than the adhesive forces, it do not wet the surface. Because it has high coefficient of thermal expansion, this implies it has high sensitivity. But what is the primary reason it is used in barometer? Because it has low vapor pressure. Because it has low vapor pressure, it is difficult to boil. Because it will be difficult in boiling, that means the vaporization is very, very less. Even if you will keep inside a container, it won't evaporate. Okay? समझ गए? Okay, so this is about your vapor pressure. Okay, now we are going to study cavitation. Understood? So our next topic is your cavitation. Okay, so we have studied vapor pressure. Now cavitation. What cavitation actually? It's the rapid formation and collapse of vapor bubbles in a liquid. Rapid formation and collapse of vapor bubbles in a liquid. Now let us study how does that happen. Let us say your fluid is flowing inside any container, inside any pipe. Okay, and the fluid is flowing at high velocity. Fluid is flowing at very high velocity. We know that when the velocity is more, what happens to the pressure? Sir, pressure decreases. Correct. That is your Bernoulli's equation, Bernoulli's law. So when the pressure decreases, let us say this is a point in the liquid where the vapor pressure is low. We know when the vapor pressure falls, when the pressure falls below the vapor pressure of the liquid, what starts? Sir, boiling starts. Boiling is associated to bubbles. So vapor bubbles has now formed. So you have high velocity. So this liquid will what? Carry these bubbles forward. This liquid will carry these bubbles forward. Now what happens? You came into a place where the velocity is more, where the pressure is more. So what will happen as soon as this is your high velocity low pressure region, and this is your low velocity high pressure region. This is your low pressure region. This is your high pressure region. So as soon as your bubbles will enter, let me draw a little exaggerated view so that you'll understand. So let us say this was your bubble. Okay, as soon as your bubble will enter the high pressure region, the bubble was occupying more space. Okay, it will collapse. When it will collapse or it will implode, it's not explode, it will implode. So what happens? There is a void, a space. To fill that void or space, the surrounding water molecules will rush in. And will occupy the space. See, the dotted line shows the vapor, the solid shows the liquid. So you understood, when this was a vapor, it was occupying more space. When it was vapor, it was occupying more space. When it became liquid, it's very, very less space. So what happens? There is a collapse, that is implodes. This implodes. Okay, will release some energy. This will release some energy. It will, what it will do? It will release energy. Energy for a very short time. The energy it will release is for a very short time, and that is concentrated at a small area. Concentrated at a small area or small space. So what will happen? Because the bubble collapsed and the bubble formed a liquid, some kind of energy is released, which is for a very short time and concentrated on a small area. Now this only we call it what? Formation and collapse only we call cavitation. This phenomenon is cavitation. Now what happens? This particular phenomenon which is occurring here, it is occurring near a solid surface. What happens when this occurs near a solid surface? What this will do? This energy which is released, there will be a microjet formation. There will be a microjet formation, and that microjet will pierce through, will damage the surface. Will damage the surface. This is your collapsing bubble. Okay, and this is nothing your microjet. This is going to damage the surface by the term what is known as localized short-term overstraining. By localized short-term overstraining, it is going to damage the surface. So after that, there will be some micro cracks on the surface, and we know the property is what? Once there is a crack developed, crack always propagates. Crack always propagates. So ultimately it will damage your pipe completely. So that's why that once there is a cavitation, there will be a flow instability because of continuously formation and collapse of vapor bubbles. Hence the hydraulic efficiency will be less. When it happens near to a surface, the microjet will damage the surface, hence we will have a surface damage. This will, you can find some audible noise, there will be a noise, and there will be pressure shock. Because of pressure shock, you will feel vibration in your pipeline. Okay, so there will be mechanical, and continuously it is collapsing near the surface. You can actually you can hear some noise. So that only we call pitting action. That means surface erosion. It will erode the material. And overall, what happens? The hydrodynamic performance of your equipment, of your product is decreasing. The hydrodynamic performance of the is decreasing. Understood? So this cavitation is a low pressure phenomena. Cavitation is a low pressure phenomena. This comes in exam. So we have something known as the cavitation number. Cavitation number. Sigma equal to P ATM minus P vapor pressure by half rho V square, where V is the velocity of the fluid in a medium or inside a pipeline, rho is the density of the fluid, and sigma is the cavitation number. So you know, when the atmospheric pressure becomes equal to the vapor pressure of the liquid, sigma is 0. Sigma is less than or equal to 0 means cavitation starts. Sigma is negative, there will be cavitation. Sigma is positive, there won't be any cavitation. Okay, I hope this you understood, okay, in a quick and easier way. And if you are not subscribed to the channel yet, please do subscribe. You like this content, please share with your friends. It will keep us motivated. Okay, thank you. Have a great day.